So, in Newton's first law, we talked about how when things are moving, they'll stay moving until you apply some kind of force to it. Or things that are staying still, they'll stay in their stillness until you push it, kick it, hit it, drag it, you do something to it. Newton's second law is going to look into this a little more in depth. What we know is that if you keep applying a continuous force to something, it is actually going to get faster and faster and faster. And that's called acceleration. As we change the speed, things are accelerating. And that's Newton's second law. So here we have a cart. And I've chosen the cart because I don't want to talk about the frictional forces. I just want to talk about a force to make it go faster. So here we have a cart. And if I apply a force to it in this direction, and if the force I apply is the same, that cart is going to get faster and faster and faster. And this comes back to the equation that we've seen previously. The force is equal to the mass times the acceleration, or F is ma. Okay, so let's take our formula and see if we can use that to solve some problems. We know that our force, F, measured in newtons, is equal to the mass times the acceleration. So an example, if a 530-gram cart, like the one I just pushed, accelerates at 1.3 meters per second squared, what force did I use on the cart? So the first thing we should do when we have any problem is identify what we have. So what I have is I have the mass of the cart is 530 grams. And remember, when we're doing this, we want to use kilograms. So that would be converted to 0.53 kilograms. Next, what do we know? Well, we know that the acceleration is 1.3 meters per second squared. So simply now I take my formula, F is ma, and I put that together. I have 0.53 kilograms multiplied by 1.3 meters per second squared. And what we are going to find for a solution that's going to give us 1.59 kilograms meters per second squared. And then to finalize this, I'm going to look at my significant digits. I got 2 digits here and 2 digits here. So I'm going to say that I have 1.6. And I know that this is a Newton. So the force applied must have been 1.6 newtons of force. So here I have another question. So let's say we have an object with a mass of 1.16 kilograms, and it's being pulled with a force of 25.4 newtons. What I'd like to know is, does the speed change? And according to Newton's second law, the answer is yes. When we apply a constant force, okay, things will accelerate. So this is Newton's second law in action. So then the question is, well, how much? Okay, so what we need to do is I'm going to say, well, I have a force here of 25.4 newtons, and I have a mass of 1.16 kilograms, and I know that my formula, F, is equal to mass times acceleration. And what is it we want to find? I want to find my acceleration. So I'm going to do a little bit of algebra. I'm going to find that the acceleration is equal to the force divided by the mass. So my acceleration would be 25.4. And I'm going to change this newtons. Okay, so it said newtons. I'm going to remember, like, no, I don't want newtons. I want kilograms meters per second squared. Okay, and we're going to divide this by the mass, which is 1.16 kilograms. And what we'll see is that our units here, our kilograms, are going to cancel out. We're left with meters per second squared, which is acceleration. And what we're going to see is that we end up with an acceleration here equal to 21.8965517 meters per second squared. Once again, I'm going to round this off to 3 digits because I have 3 up above in my question. So I'm going to have 21.9 meters per second squared is the acceleration. Now we see we have an object that has a mass of 2,340 grams. And once again, I'm immediately going to turn that into kilograms. And I see that it's at rest. Okay, so if it's at rest, it means it's not moving. Okay, that's interesting. But now I also have a time, 2.9 seconds. And now I see that it has a different velocity of 1.6, or a different speed. I didn't give it a direction, so it's just a speed. And the question here is what force was applied? So is this Newton's second law? Once again, Newton's second law talks about if we cause things to accelerate. And we can see that it went from one speed to another speed, so there must be some form of acceleration. And we know previously that the acceleration is due to the change in speed over a change in time. So we could easily find our acceleration. Let's say I'm going to take my final velocity, subtract my initial velocity, and we're going to use time or change in time. We see here that we have 1.6 meters per second, subtract 0 meters per second. That was pretty easy. And we're going to divide that by our time, which was 2.9 seconds. And we can find our acceleration would be 0.551724 meters per second squared. Okay, now that we have our acceleration, we can find our force. So we know that force is mass times acceleration. So we could find our force by taking our mass. Our mass was 2.34 kilograms, and multiplying that by our acceleration, which was right here, 0.551724. And we're going to find that the force applied was equal to 1.291034 kilograms meters per second squared. Once again, I'm going to round this off and fix my units into newtons. So we had our first dynamics equation of F equals ma. And you'll see that we're using this with some of our kinematics equations, such as A is Vf subtract Vi divided by T. So we're now going to be able to substitute many of those kinematics equations into these dynamics equations. So as an example, I could now have a simple formula that says that the force is mass times, and instead of putting A, I'm going to say it's Vf subtract Vi divided by T. And now I could use this formula to solve further questions. So here we have a Start. So here we see we have a force of 24 newtons acting on an object with a 75 kilogram mass. I have a final speed of 4.30 meters per second, and I have an original speed of 3.0 meters per second. I notice that it's speeding up, so it's got a positive acceleration. And we want to know how long. Well, basically what they're saying is, what is the time? Okay, so we know that force is mass times acceleration. I also know that acceleration, or change in velocity over a change in time, I'm going to make that a little more specific here. I'm going to say that that's Vf take away Vi divided by t. And I'm going to put the two equations together now. So I'm going to say that F is m times Vf minus Vi divided by t. And now I'm going to do the algebra. I like doing the algebra before I put numbers in there. So I'm going to have a new formula here. So a new formula. My time is my mass multiplied by the change in velocity divided by my force. So now I've got a new formula that I've derived. Simple algebra. Okay, so now all I'm going to do is I'm going to just pop some numbers in here. My mass was 75 kilograms. My initial speed, 4.30 meters per second. Subtract 3.80 meters per second. And I'm going to divide that by the force. The force in this example is 24 newtons. Okay, just going to follow my operations here. So let's see, my change in speed was 0.50 meters per second. And you'll notice I'm keeping the 0 here because it has to do with my significant digits, what the important digits were. And I'm going to, on this one, I'm going to get rid of these newtons because, we don't want to get confused. Kilograms kilogram meters per second squared. Okay, so I take my 75 times a half divided by 24. And when I do that, I end up with an answer of 1.5625. I'll do my units over here just so you can sort of see what I had. So I had kilograms, meters per second. That's right here, kilograms, meters per second. And then I divided that by kilograms, meters per second squared, which is right over here. Okay. Hopefully we got our good math skills. If you don't, we should go find a video on that. But the way I deal with this is like a fraction being divided by a fraction, and the secret on that is we convert the second fraction into the inverse of it and multiply, and we end up with that. Okay, really simple. Let's see, I got kilograms, top and bottom. I got meters, top and bottom. I got seconds up top. I got seconds down below. Look at that. I'm left with seconds. So my time here is seconds. Looking at my digits, I need 2 digits. So I'm going to say time is 1.6 seconds. So once again, what we had this force being applied to a 75 kilogram object. We saw that there was a change in speed. Change in speed means there's an acceleration. How long was the force applied? 1.6 seconds. Okay, here's another sample of a question that combines our different dynamics equations with our kinematics equations. Once again, I have a box with a mass of 17 kilograms, and it's being pushed a distance across the floor of 50 meters. We have an initial speed of 8 meters per second. Let's make that 8.0 meters per second. and it has a final speed of 12 meters per second. And we want to know what force was used. Okay, so let's think of our equations. Well, we know that F is ma, and we know our mass, but we don't know our acceleration. So I need to find some kind of formula that gives us acceleration. Well, what do I know? I know two different speeds and I know a distance. So when I look through my kinematics equations, I see that my final velocity is equal to my initial velocity plus 2 times the acceleration times distance. So I needed to find an equation that had acceleration in it that also had the distance and the speeds, because that's what I was given. Go back to your kinematics notes if you need help, but we can find that the acceleration is your final velocity squared, subtract your initial velocity squared, divided by 2d. So what we can do now is we can now substitute this into our main formula. I'll write it in purple here. F is, I wrote it backwards. I'll just do it this way. Vf squared minus Vi squared times the mass divided by 2d. Look at that. We get another equation that we've now created based on our previous knowledge. So once again, our force is equal to the final velocity, which was 12 meters per second, and that's squared. I'll put that in brackets. Take away the initial velocity, which was 8 meters per second squared. And then from this difference, we're going to multiply it by the mass. The mass in this example was 17 kilograms. And then we're going to divide the entire thing by 2 times the distance, and the distance was 50 meters. So let's see. This is going to give me 144 meters squared per second squared. Subtract 64 meters squared per second squared, multiplied by 17 kilograms, divided by 100 meters. Okay, so I'm going to do some, let's see, 144 take away 64, that looks to be 80 meters squared per second squared times 17 kilograms. Divide that by 100. Okay, so 80 times 17 divided by 100 is going to give me 13.6. Let's look at my units here just to see if we got this figured out. I have meters squared per second squared times kilograms divided by meters. So what I'm going to end up with is that this meter is going to cancel out one of the meters in the top. And I'm left with meters times kilograms per second squared. And we know from our previous knowledge that that is a Newton. So our force is 14 newtons. The key thing to recognize here is that there are many, many, many equations that we could make up. But what we're going to do is we're going to stick with just a couple simple formulas, like what we had here with F is ma. And then we will just use the 4 kinematics equations and substitute them in as needed. We don't need to go in and memorize another 100 formulas. The F is ma and our 4 kinematics equations will help us solve most problems.